Last and but not least, Mr. Wahid Fazelly. He's a member of my own team, of the team of IB&T Software GmbH. And there he is a customer consultant and responsible for sales, for support, for consulting in the northwest of Germany. He studies geomatics at the Hamburg Hafen City University at the HCU in Hamburg and works in the support for Amberg Technologies and the Bundesanstalt für Kartographie und Geodäsie. I cannot translate this. And since 2018, he is in our team, the specialist for geodesy and rail. In his free time, he loves to do sports and also reading. Maybe he will read the book with the bucket and with the tooth is in front of the bucket. This is a nice gift for Christmas. The title of his presentation is Part 1, BIM Railway Design based on point cloud data. This is your stage, Wahid.
Thank you very much. Uwe, I'm calling him Uwe because he's our managing director, as mentioned. Thank you for the introduction, and I also welcome you to my presentation, which is called Part 1 BIM Railway Design based on point cloud data. The agenda about this few minutes I have is I will shortly describe about us, about our group, and about our main solution. Then I will go into a practical example, which is the main part of the presentation. Within that practical example, I will go through the single steps to receive a result, which we will see then within the software. At the end, I will try to provide you a summary and an outlook into further developments of our solutions. About the IB&T group, as you can see, it consists of these three companies, GeoDigital, RCD Software, and IB&T Software, in which you can see Cut 1 is on that picture. We will today only focus on Cut 1, and therefore I continue with the next slide. Cut 1 is the all-in-one CAD, all-integrative solution for surveyors and planners in civil engineering. We cover a lot of aspects within our software. As you can see, the surveyor can use our software in the field, for example, with a graphical field book, for example. He can transfer the data for further plannings like road planning or railway planning, and then at the end, you can either export the data in an appropriate format, exchange format, or you can use Cut 1 not only for construction issues, but also for drawings. So we are an all-in-one solution for drawing and construction. Today, we are focusing on railway planning, and within the railway planning, I can say from my side, even I am part of the company, congratulations to 30 years of IB&T specialization in railways, and it started really like 1991, and it continuously developed into a BIM solution, which is the topic of today. Today, I will also introduce you a new feature. It's not a module. For your information, Cut 1 is a modular system, so we can specify, individualize the working stations according to your needs. And this is not a new module, it's a new functionality called track based on point cloud. The track based on point cloud is within the point cloud evaluation module, and with that you can integrate point cloud data to get track data and track geometry. Later on I will describe in more detail what is track data and what is track geometry. You know, when we're talking about point clouds, there are different ways to integrate point clouds, not only integrate, also to acquire and survey point clouds, but also to integrate it. For CAD1, it doesn't matter. We can integrate any point cloud format from any company. So in this example, we focus on a point cloud which we received from Regal. It's a mobile mapping system which drove alongside the track and had 2 scanners with IMU and GPS. But you know, it's just an example. There could be any other example to receive the point cloud data. And with that point cloud data, we receive also some more. So the example is saying, is demonstrating you how to acquire data, how to integrate in CAD1, and how to build a 3D model, and how to export it within the BIM process. So the objective was determine the current track data and the track geometry as mentioned, and then build up and complete a 3D railway structure. Within CAD1, you can visualize that railway structure with really individual attributes, which we are always talking when we talk about BIM. It's not only geometry, it's also about the information inside that elements. And also, you can do clearance analysis and clash detections. At the end, of course, the data needs to be handed out to the next level, which would be an IFC export of that attributed objects. So these are the objectives. And so with that data, we measured, and with that system, VMX 450 Rail, we created a digital twin, and we received just XYZ point cloud data with intensities. The result, as I mentioned, were 2 point cloud data sets. Each were georeferenced and had about 66 million points. Besides this, as I just mentioned before, we receive in general also a trajectory, which is a space curve, by the system itself. If not received, it is possible within CAD1 to construct it by your own. So the trajectory is also needed to do and start the steps to fulfill the objective. So we received the point cloud data and imported it into CAD1. Very easy, everything is known for years. What we did was just to color it with RGB values so we can have a difference between the 2 scanning data. Also, we imported the trajectory, which then was our kind of auxiliary alignment. We used that for auxiliary alignment. When we talk about BIM and 3D, of course, we need also a digital terrain model, and this was also possible with the point cloud data. So this was the source we had. We had the point cloud data, and with the functionality of CAD1, again, within the point cloud module, we can calculate a DTM along, along alignment. So the new function, what is it doing? The new function detects the railheads from the point cloud data in the specified station along the auxiliary alignment. And the 2 rail points were determined simultaneously in each cross-section. They are averaged and then given the lower height and saved directly as a sorted set of points. Information like gauge and rail profile, here, for example, 1.435, which is the standard in Central Europe, Germany, and rail profile, they should be obviously predefined. From the middle top and inside of the rails, the appropriate track access points, the cant, and vertical alignment heights will be calculated. Finally, all this information, which then is very accurate, can be visualized and checked in the appropriate CAD1 band views. Our opinion is that the results are very accurate. The first expression I can say is they are as accurate as the point cloud data is. So if the point cloud data was measured and recorded accordingly, then CAD1 is not doing any mistakes. It can interpret it really in an accurate way and generate the geometry. For example, the mean deviation from the track width, okay, it's saying gauge, it's the gauge, is according to our analysis plus minus 3 millimeters. That video now starting shows CAD1 with all its different windows, and it takes about 2 minutes. I'm starting it. So what is happening? We have here the cross-section view and the vertical alignments. First of all, we do the test. We have on the left the point cloud data, and we are testing what's the gauge. And we see it's 1.43 some kind of, so which is very close to the nominal standard. Then we start the script. We could import the trajectory, but we already imported it. This is the data we receive. So we can immediately start the script to generate the track geometry. We choose the point cloud data. We choose the auxiliary alignment, set up the station area. As I said, gauge and rail profile are already predefined. And then we say, please generate us a new track, a new real track with the number 100, and please generate it. Then next, it tells us with the 2 yellow arrows to choose the rail top middle. We have to do it only once on one station point, which was about 1,500. I think I said this point was set. And with that information, the script is running and calculating you the track information and the track geometry. So it's not cut it really goes that fast. This is about a station area about 350 meters. I could even take a longer range, but I think for this demonstration purposes, it's fine. It's done. So now we small up the existing window and open the new just created axis 100. And we see it looks like this. We also see a building, which I will demonstrate now within the next presentation, but this can be taken as is and can be used for further planning purposes. So far, everything good. Now, when we have the track, we can jump into the next, which is the BIM Railway Designing. This is not a new feature, but we continuously develop it, and it's very simple. You need a track, you need heights, and then you define the parameters. The parameters are the elements, for example, for the switches or for the rails. So you can say which switch, for example, with which parameters I want to generate. And when you're done with that, you generate the rail, and then it's designing it from big to small, I wrote down here. So it will create it. And you not only get cross-section lines, you also get a full object, a track object. At the end, we can visualize it and do drive simulations. CAD1 is able, and also supporting virtual reality, and we have a 3D project view. So appropriate video shows the information I just mentioned. So now I increased the 3D project view on the right, and we have enabled the point cloud data. He's a little bit moving around, showing you that everything is okay. And then we start from Verkehrsweg, route planning, the module, which is a module called BIM Bahnkörper. We will not define now new elements and change it due to lack of time, but you can see now the information you just mentioned. Important is to choose the just created axis 100. And for BIM purposes, we have the possibility easily to access the attributes to edit and define appropriate attributes to each element as switches, or as I mentioned, or the further elements, the cable canal and so on. So everything is okay, so we can start the generation. And here also we have to define the station area. We choose the same as almost as before. A DTM has to be considered. It is. And then we can choose between station list or an fixed station. We choose 10 meters station. And then we say, please generate a railway structure. Some further settings could be done there. And this is again about the same area. And you see also the cross-section lines on the yellow. Everything went very quick. Now we go into 3D project view. We enable that just created railway structure. On the right, please, look on the right. And then we can move along and see. We now disable the point cloud data to see the result. There are so many possibilities to define that railway structure. I choose now a very simple way just to see the possibilities. You can here take instead of Weichen, instead of hood, Weichen, steel, Schwäne, slippers, I forgot the word. You can change anything you want, and you can see if you grab that element, you see all that attributes we defined within the Excel file. Now, inside Cut 1, we start an animation, just possibility to do that, and you say start from 1400, and then you can drive alongside the track. If we would also already define a clearance, you could also see like the clearance profile, and you could then, when this is done, so this was the visualization, you could also then use that clearance, that kind of space curve which we provide you by per standard for clash detection purposes. Clash detection between the profile and the point cloud data we have. It can be another point cloud data set, not the one we had from as a source. It can be another one. Or you can also use the clash detection with any marked points alongside the track. These few pictures kind of show it. And at the end, of course, you can also, again, visualize it, export it, and do animations. Talking about BIM, we are talking about data exchange formats. Cut 1 is supporting per standard IFC and CPI XML. We are looking ahead into IFC 4.3 and also into further developments in railways. Very simple, you could export then that just created BIM railway structure via IFC while choosing that appropriate buildings and objects, and then export it either directly into Cut 1 DSite Share, which is a DSite viewer. You can download it via our website for free, or into our partner Think project, E+ partner solution DSite BIM, which was just shortly introduced here, and it works very fine. And then you can use all the buildings and models for further tasks. Summary, objective was fulfilled. Cut 1 proved that we are an integrative all-in-one civil engineering solution from surveying until BIM export. And as I already mentioned, Cut 1 can read all kind of point cloud data. The accuracy was fine, and the generation of a railway structure for BIM purposes was, from my point of view, very simple. Outlook, you can look ahead at we're still in version 9.1. We just integrated the 3D switches within our solution. Time couldn't allow me to show it also. And then we are running ahead to version 10. And we have all that kind of topics in our board or wherever in our book. Slab track is one of the topics, deep drainage, electrifications, continuously increasing our 3D symbol catalog, and much more. Thank you very much for your attention, and if there are any questions, I'm here or on our booth at C20.
First of all, an applause for Wahid Fazelly. And I think we have some question. I learned from you that it's very important to extract the needed information from the as-is model, not as-built model, the as-is model, not to use a lot of information, to extract exactly these information you need to design then the new railway based on the situation, on the real situation, so to extract the alignment and to use then the alignment for the new design, and then after this in very efficient short steps to create your design model. So we have an answer from the auditorium.
Hi.
Hello, hi.
Thank you for this really great presentation.
You're welcome.
You worked at the Federal Geodetic Institute.
Yes.
So I ask you a question about georeferencing.
Okay.
And especially the scale. Could you please elaborate a bit how you handle scale and georeferencing in the point cloud, in the trajectory, and then with the IC export?
Okay. Thank you for the question. The trajectory was delivered by the system itself. So we assure that this data is already georeferenced. If it wouldn't be georeferenced, we wouldn't get that result, as I mentioned, for example, for the gauge of 3 millimeters, yes. But also within the software, it is possible, if we have point cloud data, to, for example, transform it into that project's coordinate system. So the possibility is also within the point cloud module included, that you can, if you predefine the coordinate systems, that when you import that point cloud data, it will directly be in that project's coordinate system. So I hope this was the answer. Okay.
Okay, some more questions? I learned online we don't have any questions. If there is no more question, I can invite you, if you are interested, to learn more about two of these solutions, about A+, about D-Side, about Card 1. We are on the exhibition in Hall 20. You're invited to come to us. We will present you a little bit. There's also a coffee for you if you want. Thank you very much to be here, and thank you to the three presentators or presenting persons, that's the right definition, and thank you very much, and I hope to see you maybe in the afternoon. Thank you.